Hey class, this lecture is on the lymphatic system, starting with a background on the lymphatic system and looking at the primary lymphatic organs. So let's talk about the three functions of the lymphatic system. Some of these we'll cover in more detail and some we'll just briefly mention. First is maintaining the fluid balance of your body. Second is immune defense, and third is fat absorption. So let's talk about these a little more. When we say maintain fluid balance, what we mean is that the cardiovascular system delivers oxygen and nutrients to your tissues by being very leaky. Remember, we learned that there are three types of capillaries. Some are leakier than others, but they're all leaky. That's good. The fluid that leaves the blood vessels carries with it vitamins and nutrients and sugars and electrolytes and oxygen. And so we bathe our cells in this fluid. But the cardiovascular system is not so good at recollecting that fluid. In a day, about 20 liters of fluid leaks out of your vessels, and only about 17 liters gets pulled back into your vessels. So imagine what would happen in just one day of not having a lymphatic system. You would have 3 liters of fluid that would just kind of be loose in your body and would get pulled down with gravity to wherever gravity brought it. And this is what we call lymphedemas, where this fluid collects where we don't want it to. So the lymphatic system's job is to suck up that remaining 3 liters of fluid and get it back into the blood. The problem is that fluid has now been kind of circulating around your tissues and could have picked up who knows what, a virus or a bacterium or whatever. So before it goes back into your blood, it will stop by some lymph nodes to be filtered. So maintaining fluid balance is one of the functions of the lymphatic system. A second function is immune defense. Here we see all the types of blood cells that can be made from one multipotential stem cell. And many of these cells are involved in immune defense, especially lymphocytes, since we're talking about the lymphatic system. So lymphocytes are shown here, but there's also natural killer cells and macrophages and neutrophils. Lots of cells here are involved in the immune defense. So we'll talk a bit more about specifically the lymphatic system's role in immune defense. But one thing that you've probably already experienced in your life is a physician checking your lymph nodes, maybe especially your cervical lymph nodes under your jawline. Because those lymph nodes are very near your ears and your mouth and such, if those are swollen, if those have a lymphadenopathy, swelling of the lymph glands, then they indicate some trouble, some reason that your lymph nodes are responding to a threat to your immunity. So lymph nodes are part of the immune system, which we'll talk about more in a bit. The last function of the lymphatic system is fat absorption. And it might be hard to imagine this, but your intestines are not smooth walled. They have all of these tiny little structures on the surface of the intestines called villi. And the goal of these villi is to improve absorption of nutrients from your food. We'll revisit this in the digestive system, but here's the short story. Little nutrients can get sucked into the blood vessels of your villi. And then those blood vessels carry the nutrients and maybe toxins and stuff back to the liver, and the blood gets processed and everything's good. Lipids, these big chunky fat globs, end up sticking to each other and making even bigger fat globs. They can't get into the cardiovascular system. So instead, while the lymphatic system is vacuuming up this 3 liters of fluid, it also sucks up the fats. So it absorbs the fats. And then the fats will travel through the lymphatic system, maybe go through some lymph nodes, and eventually all that lymph, remember, goes back into the blood to maintain the fluid balance. So now the fats have eventually made their way back into the blood just through a different pathway. We'll revisit that during the digestive system. Okay, so those are our three main functions of the lymphatic system, and then we will be kind of revisiting two of those as we go through these other structures of the lymphatic system. So we want to talk about what is lymph, what are the lymphatic vessels, and then we'll look at the lymphatic organs and immune cells. So lymph is this fluid, Latin for water. It's clear, although green is the color that's used in diagrams and figures and models to indicate the lymphatic system. But lymph is mostly water. It's a clear fluid. And as we discussed earlier, it comes from the blood. Blood is very leaky. So all this fluid that leaks out of the blood to bathe our cells in nutrients, as it leaves the blood, we call it interstitial fluid. It's the fluid in this in-between space. 17 liters of that per day will get drawn back into the blood vessels. The 3 liters that stays behind, that's called lymph. Once it gets sucked into the lymphatic vessels, we call it lymph. What are these lymphatic vessels? Well, you can see here that they're interwoven with the capillary bed. But if we look more closely at just one lymphatic vessel, on the end, we can see that there are these mini valves, these little micro valves. Those are where the fluid gets drawn into the lymphatic vessels. Those are where the fats can enter the lymphatic vessels. And these lymphatic capillaries is what they're called when they're very small. Those capillaries will merge with each other and form larger and larger lymphatic vessels. These vessels are kind of like veins. They're low pressure, so they have valves to help keep the lymph moving in the right direction. And they rely on similar mechanisms to help the lymph return, especially up from the inferior portion of the body. Lymph draining down from your head can use gravity to kind of make its way back towards the subclavian veins, which is kind of the end of all of this. But our goal is to get the lymph into the veins under your clavicles. So it's easy for the lymph to trickle with gravity down from above. But to move the lymph up from below requires things like the skeletal pump and the respiratory pump that were discussed previously. So now we'll just look at some major lymphatic vessels. There's a diagram shown where I deleted the other structures, and I've just left a few of these vessels. One is the cisterna chyli. A cistern is like an old-timey word for a big pot. So this is this kind of big lump of lymphatic vessel, and it's collecting all the fluid that's coming from the abdomen and the lower limbs. So that fluid's been drawn up, up, up. It's reached the cisterna chyli, and now what? Remember, the goal is to get that fluid up to the subclavian veins. So that fluid will then move into the thoracic duct, kind of up the middle of your thorax, and that blood will move up, up, up. That lymph will move up, 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 and eventually reach your subclavian vein, and that's where the thoracic duct dumps all of that lymph. There's an image showing that thoracic duct, it collects almost all the lymph in your body, all the lymph from your abdomen and lower limbs, and from the left side of your head and chest and arm. But you do have one other big lymphatic duct in your body called the right lymphatic duct that will collect the rest of the lymph from the right side of the head, the right arm, and the right thorax, and dump all of that lymph into the right lymphatic duct, into the right subclavian vein. So 2 passageways for all of that, 3 liters of lymph per day to get back into your bloodstream. But don't forget that lymph needs to be cleaned, needs to be exposed to immune cells to make sure there's no bacteria or viruses or cancer cells present in the lymph. So for that process, we need to use our lymphatic organs. We'll talk about the primary lymphatic organs now, and next time we'll talk about the secondary lymphatic organs. So what makes a primary lymphatic organ a primary lymphatic organ? What makes the thymus and the red bone marrow so much more special than lymph nodes or the spleen and so on? And the answer is that the primary lymphatic organs are the sites where lymphocytes develop and mature, where they become immunocompetent, competent at providing immunity to your body. So let's look at this red bone marrow here. Red bone marrow is where hematopoiesis occurs, the creation of all the blood cells. So thinking about B cells are made in the bone marrow, and they make antibodies. That's what B cells do. But they're made in the bone marrow, and then they hang around and they mature. And when they're ready, they will migrate to somewhere else in your body, let's say to a lymph node. So bone marrow gets to be called a primary lymphatic organ because it's the site of B cell maturation. What about T cells? T cells are a type of lymphocyte, so they're made in the bone marrow, like all blood cells. But after they're made, they immediately migrate away to the thymus. So the T cells go to the thymus to mature there. That makes the thymus a primary lymphatic organ because it is the site of lymphocyte maturation. And once they're mature, then the T cells too can migrate somewhere else, maybe to a lymph node, to provide you with immunity. Other notes on red bone marrow, don't forget we call those cells pluripotential stem cells that make all these other blood cell types. And although we've talked about B cells and T cells, there are other immune cells like NK cells, natural killer cells, and macrophages that are made in the bone marrow. We'll talk about those later. And red bone marrow in adults is found in some specific places: the pelvis, sternum and ribs, some of your skull bones, and at the proximal ends of some of your long bones. These primary organs, red bone marrow and the thymus, are vital for your survival. And so when there are diseases that affect them, that's when you get into things like bone marrow transplants.
So I'm just going to start with a little bit of lidocaine.
Okay.
And do you have a marking pen? Yes. I'm going to mark on you, but okay, so ASIS, inner and outer. So what I usually like to do is hold the inner and outer tables. Once you can hold the inner and outer tables, you've got control. And then you know the direction it's going. So you go about 2 inches behind it. You're doing perfect. Yes, I am. Gotta get you not to laugh. It hurts my fingers when you laugh. Gotta get the periosteum, okay? So once you get the periosteum, it becomes a painless procedure, and that's what you want. I always like shoot down the inner and
Dr. Green said I didn't deserve to be famous.
Dr. Green is just mean.
Me, Dr. Green.
Okay, that's a little in the inner and outer table. We use a lot of this. The more we use, the better it is, right? You don't even feel that now, me touching your bone.
It is happy hour now, but I know it's a comic relief swapped around there.
Just a, not yet, just a 4x4. So what I do is the easy part, massage it in.
Oh, this is nice.
It's the best part.
Yeah. Put this on my bill.
Secret is have your fingers on the, some people you don't have that advantage to do it, but as long as you have your fingers on your inner and outer table, you're fine. And I like lidocaine because it's quicker. So some people make a cut. I don't. So Andrea, just come on this side. Okay. How's that? You good?
You asking me?
Yeah.
I'm good.
So what I do, especially in this case, is smell it. Okay.
I'll let you know when I'm not okay. We gotta,
Okay.
that doesn't help.
Try to keep steady with that as much as you can, because even when you laugh, okay. So there, we're in. So you hold a tip, okay? As long as you hold a tip, you got it here. I'm in between. Always be cognizant just to taking out and putting in. There's a pressure phenomena. So now we're in between the inner and outer crust. Gonna make sure this is all the way in. And it is. Now you're fine. Is that okay? It's the worst, okay? So we're nice and deep. Now,
These locked up.
yeah. Sorry. So just take a deep breath. This is probably the strangest feeling. Deep breath. But you're doing great, okay?
I appreciate that. I appreciate the positive feedback.
This is the part you can't control with local as much. What's it feel like just for...
You know what? There's actually not much of a sensation. There was only just a little bit when it penetrated. When it penetrated, I felt a little tenderness because there's sort of a little vulnerability that was exposed.
Yeah.
But other than that, no, at this point, it doesn't. There's a psychological effect of hearing something pounding, that you think something must be penetrating. But no, there was just a tender, like a raw nerve feeling, but more of a deeper sensation, I guess.
So here's the deal. I mean, we actually have to get in deep here. If you don't get in, this is pretty deep, okay? This is actually very easy. If you go in superficial, you're not going to get the good bone marrow, and it's going to be a little tougher. And he's also locked too. Halfway done.
So that was one of the two primary lymphatic organs. The other is the thymus. Very briefly, we'll just say it sits on top of the heart. It's large in children, but as we get older, it atrophies, becomes a lot of fat and connective tissue. And it's made of two large lobes, one on each side, and those lobes are made of little lobules, little mini lobes. In the cortex of the thymus is where T cells will mature with the aid of a hormone called thymosin. And just like red bone marrow, you really need your thymus. And I want to make sure that's very explicit because secondary lymphatic organs include things like the spleen and the tonsils and the appendix. And you'll hear about these things being removed, and the consequences are pretty minimal. If you remove the thymus, you can never fight any new novel infection that you encounter. So the thymus and these T cells are really the key to kind of your most specialized part of your immune system. And we'll talk about that next time when we look at secondary lymphatic organs and immune cells.